The process is started in receiving by verifying the correct parts are delivered to the dock. The packages of parts are then received into the system and labeled with an Incap part number and other identifiers. Some parts are subject to inspection upon arrival to ensure that they meet the quality standards of Incap and its customers. Once received in, component parts are stored by customer and categorized by part type in staging. When an order is scheduled to be built, a list of parts needed for the order is generated. The parts are pulled from stock and issued to a kit. Kits can sometimes have multiple subsets of parts. These are brought to each department so that everything needed is there. Most modern circuit boards are built using surface mount technology, or SMT. Surface mount components are placed on copper pads on the surface of the board. SMT is the core building technology, allowing electronics to get smaller and smaller. Components of this style can be as small as a speck of dust. To begin a build, an automated feeder feeds the bare printed circuit boards, or PCBs, into the stencil printer. This stencil has precisely cut openings where solder is deposited on the metal pads located on the board. To start, the stencil is pressed down, and a squeegee rolls a bead of solder paste over the stencil. When the stencil is lifted, a precise amount of solder is left behind. Next in line is the solder paste inspection machine. This machine uses cameras and computer software to determine if the print was good and the correct amount of paste was deposited at each location. Once this machine gives the OK, the board proceeds to the next step. This brings us to the pick-and-place machine. Parts are loaded into this machine containing the surface mount parts that go on the assembly. Using a vacuum nozzle, it picks up each part. The nozzle is passed over a scanner to ensure the part has been properly picked up. It then places each component at the correct position on top of the solder paste on the board. This machine can place over 12 to 15 parts every second and can place anything from large chips to microscopic parts. The PCB is fed down the line into an oven. This special reflow oven has multiple zones with customizable heat settings that ensure each board is heated up at the proper speed and to the proper temperature. The heat will peak for a short period of time. This is when the solder paste will melt and weld the components to the board at the same time. The soldered PCBs are then fed into an automated inspection machine, or AOI, which uses multiple cameras to take pictures of the board. It uses computer software to analyze these images and flag any parts that may not have been soldered correctly. Once the AOI gives the OK, the board is ready to move on. Some PCBs have parts placed on both sides. These are run through the SMT process twice, with 2 different recipes at each of the machines we went over. Not all parts are considered surface mount. Some are known as through-hole. They are parts either with attached wires or metal pins that are put through a hole in the board. Though less common than SMT parts, they are still an integral part of circuit board manufacturing. Many assemblies use both SMT and through-hole parts. Much like the SMT pick-and-place machine, there are automated machines which place through-hole components into the board. These machines are specialized to place common, specific types of through-hole components into the board. Through-hole parts can be many different shapes and sizes. At slide line, all of the parts that cannot be placed by the machines are inserted by hand. Instructions are placed along the line, telling the operators what part to place, where to place it, and how to orient it. Operators insert each part at their station into the board and then move it down the line to the next station. Once all parts are placed, the board is sent into the wave. The wave is a wide fountain of molten, constantly flowing solder. The board is heated up as it moves up the chain approaching the wave. As it passes over the pool of solder, the solder flows up the holes and welds the leads to the board. Depending on the parts placed on the bottom side of a board, sending a board through wave may not be possible. Incap has a specialized machine called a selective solder machine that has a miniature wave attached to a robot arm. It can be programmed to move over select paths on the board. Even if a part is surrounded by other parts, the selective machine can move between them to solder only the through-hole parts. Not everything here can be done by machine. Some operations still need to be done by hand. These are done in the Second Operations Department, or Second Op. Here, additional hardware and wiring is added to assemblies by hand. Because of flux, some assemblies are required to be cleaned after they are built. The wash here at Incap uses a special water and chemical mixture to wash away the flux residues left by the solder process. Assemblies built are then tested to ensure that all parts placed on the board are good and soldered, and the board functions as expected. At the in-circuit tester, boards are loaded into special fixtures designed for each assembly. The vacuum pulls down the fixture and pushes the board onto spring-loaded needle-like probes. The probes contact points on the board and use electrical measurements to confirm that parts are placed, soldered, and have the correct value. Functional test is the next step. The goal of functional test is to make sure all of the individual parts function together. Tests at this step can vary wildly in complexity. Sometimes it's as simple as measuring voltages or programming the chips on the board, but sometimes a full performance check is done, measuring, tuning, and calibrating every function on the board. Sometimes circuit boards are used in environments that aren't as comfortable as a household living room. Conformal coating is added to boards to allow them to better resist external contamination. The conformal coating machine uses a robot arm to spray a coating to necessary areas to seal them away and ensure reliability in harsh conditions. Before assemblies are ready to ship, they are subjected to one final inspection after all other processes are complete. Here, we confirm that all prior steps were completed and that everything is ready to go. If you've ever zapped yourself on a doorknob, you've been shocked by thousands of volts of electricity at once. This level of electricity can damage electronic assemblies. To prevent this, all boards shipped from Incap are wrapped in a special bag that removes electrical charges, as well as bubble wrap that's formulated specifically to not generate electricity. This keeps them protected so they safely reach the customer.